Next, it's my privilege to introduce Dieter Krummer from Advanced Technology Solutions. He's presenting today on about his composite structural building system. So over to you, Dieter.
Good afternoon and welcome. Pleasure to be part of the presentation. We're developing structural building systems. Our closest cousin would likely be a fiberglass composite system. Next slide, please. We'll go right to the next slide here as a mission statement, new building systems. This is our typical profile. We can pre-build our wall sections in factory, or it can be assembled on-site. The main component is an H stud system that can be used particularly for basement and foundation walls, filled with EPS insulation or conventional type of insulation. And of course, on the thermal transfer, we have a very thin web that's about 1/8 or 3/16 thick. So of course, the thermal transfer from outside to inside doesn't happen, particularly it doesn't happen well through this type of composite material. And of course, it's very energy efficient, even when compared to conventional 2x6s or other materials. It's fire resistant. We're infusing that with our own particular formula. Has no outgassing. We can go up to a structure 35 foot high. So we're competing against conventional steel structure buildings that use curtain walls. And they do not rot or deteriorate, so ideal for farm buildings, etc., where ammonia or other chemicals are present. Next slide, please. So again, they're very easy to sterilize. You can go at it with some water or some chemicals, mold resistant, chemical resistant. We can put these up in hot or cold climates. Relatively lightweight when you compare it even to lumber. You can easily manage, one man can easily manage a 12-inch type of material that's 20 feet long. It's cost effective to produce and has very little outgassing, doesn't produce any greenhouse gases. Particularly interesting now is prefabrication for larger panels to expedite the construction at different job sites, commercial or residential. And certainly we'd like to see some residential applications, particularly if they're in remote areas. Next slide, please. So this is our typical floor joist. Coincidentally, we're testing these today. Up to 20 feet in length is what our equipment is able to test. And we're taking this up to loads of well over 5 tons per member. It outperforms steel beams in the way that even if it deflects, it doesn't retain memory, it bounces back. We can cut ductwork through that to allow for installation of ventilation and plumbing. And it has a very high compressive strength. As a matter of fact, it's about 95% the strength of steel, but it can be worked with conventional tools such as saws and grinders. So very light and easy to work with in the field. We can make custom sizes available. Currently, our floor joist systems are an 8-inch and a 12-inch system. And we're just developing our load charts for that to be able to pass it off to engineers for their specifications. Next choice, please. Okay, this is our typical testing. So currently, this is one single member wall stud being tested to a load of 2 tons. Or 2,000 kilograms. The little left slide on the bottom is a test of a wall panel, and we've taken these up to 15 tons load. Currently, without failure, we haven't tested yet to the failure, but I'm supposing it's probably double of that. Next slide, please. This is a little sample of the wall section. Here we're showing in MgO board, magnesium board, attached to one side. And of course, the other side can receive whatever type of finish, whether that being a drywall finish or a custom type of siding that we've developed. Next slide, please. This is our little sample home that we're constructing. The floor joists are right now an 8-inch floor joist at a 15-foot span. The outside walls a 6-inch wall stud. And we still are using some of the wooden construction, such as the funky roof that we've designed to give this a little bit of sex appeal and to make us stand apart from other construction techniques. We're incorporating custom type siding for this as well, which eliminates the use of OSB board or of other cladding material. This particular home is for sale momentarily. If somebody's interested, has a place to put it. It's 1,000 square feet, or just under 1,000 square feet, 90 square meters. Give me a shout if you're interested. Next slide, please. So we're the first in the market with composite structural materials. There are other manufacturers of a composite material similar to this, but not on a structural basis. And we're doing our integrity testing at this point and certifications. Again, it's certainly a lot lighter than most construction materials, so easier to ship, easier to install, very cost efficient. And best of all, it has very little or no thermal transfer. For example, steel will have a transfer coefficient of about 50. We're at 0.004. Next slide, please. What's our target market? Industrial buildings, warehouses, farming. In particular, we looked at hog buildings before. Would be a good application together with a particular cladding. Hydroponic certainly seems to be in the news as of late. Fish and shrimp farms, certainly some new homes. We've even talked to some architects that would like to use it for apartment buildings up to 6 stories. They said, yeah, our material should suffice for that. Cooler freezer storage units. We have done sample units up to 9,000 square feet. Food processing plants, maybe emergency shelters, or some of the target markets. Next slide. So if you have an opportunity to talk to us with respect to different projects that you might be considering, certainly we'd be looking at maybe incorporating some of the other technology that's available, some of the other presenters. I'd be more interested to talk about that, and particularly on the electronic side, how can we make this little show home operate more efficiently, maybe in together with solar panels and so on. So that would be of interest. Next slide, please. My name is Dieter Kromer. You can reach me at advantechstructures@gmail.com or on my cell phone. Appreciate it. Thank you.
Fantastic. Thanks, Dieter. Is there any questions for Dieter right now? We have a few minutes here for questions.
Hello, here's Haita again. Yeah, very interesting product. I just have 2 quick questions. One is how to connect them together, because we know the wood, we will use nails, just nail them together, and for light gauge steel, we know we use both. But for your product, how to connect the elements together? Another thing is about the cost for you for this kind of product compared to, for example, dimensional lumber, 2x6, just for example. What is the cost differences for example, per stud?
We generally quote on the job, so I'm not prepared to disclose our pricing structures. That's all relevant then to the project. At this particular point, we are very cost competitive to 2x6 structures. As that, those products have become like gold, particularly the plywood and so on. So we are competitive in the marketplace. I think, however, our sweet spot would be for basement foundations competing with concrete, as it's time saving. much more efficient, much lighter, requires a smaller footing. So there are other savings that come along that can be factored in, and not just a per lineal foot comparison of that. And for commercial structures, if you've ever tried to buy a 2x4 that's 20 feet long, you won't find any, and the ones that you will find are certainly not straight, where our product is always straight and true, and certainly has a higher performance rating than that. So it's not as easy as comparing 1 foot of 2x4 against another product. There are many other factors that come into that. The fasteners that we use is a special screw fastener for assembly. Does that answer your question?
Yeah, thanks.
Okay, thank you.
Perfect. Thank you. So thank you for that. Really interesting. It's my pleasure.